What's up? What's good? What's up? What's good? Listen up, listen up. I'm here to help with math. That's what I'm here for. I'm here to help with some math. I'm the math help, preferably middle school math. If you're between the grades or middle school, high school math, math help, math help, math help. I'm here to help with math. I'm here to help with math. While we're waiting, I'm gonna do something math related. All right, I'm here to help out with math. I'm here to help out with math. I'll get some sleep, but the thing that's keeping me up is this math. All right, so I'm gonna just start off, whether you need the help or not. What's going on? Fractions. Ooh, I just said a bad word to somebody. Fractions. Fractions are very easy. All right. What the fladoodle are fractions. All right. What the fladoodle are fractions. Fractions make your life a lot easier, right? When someone sees something like this, and they're like, everything's backwards. So I gotta write things backwards. When someone sees something like this, right? When you see something like this, they're like, what the heck is the answer, right? That's the answer. All right? Fractions is a different way of thinking of a number. But people are like, but there's more than one number that represents a fraction. Well, isn't this number made up of more than one number? So here's the thing, right? Fractions, you guys know what the word fractured mean? Like you fractured something? Like you ever fractured a bone? Like, I don't know. I know people that, like my little brother, he broke his wrist. He fractured his wrist, right? His one bone got fractured into two pieces, but it was originally one bone. So if you take a piece of something and you break it, that was years ago. You take a piece of something and you break it, it becomes fractured. If you take a piece of one and break it, now they are fractured pieces. One broken up into many pieces, you have fractions of the one thing. Fractions are numbers less than one, but greater than zero. They're numbers less than one, greater than zero, meaning they're less than one. However, they're not less than zero. Those are negative numbers. We're talking about numbers between 0 and 1. Numbers between 0 and 1. Oh, that's backwards. But you guys get the drift. Those are what you call fractions. How do we know a number is less than 1 is a fraction? I know this is basic stuff for people who know. I don't care. All right? I'm going to tell you anyways. We represent fractions by a numerator, a line, and a denominator. All right? Thank you for being a fan. Right? The numerator, mind you, this is animation that I made is in there. The numerator goes on top, right? So let's say the top is 2. So to complete this fraction, a proper fraction, you got to put a number that is greater than 2. So it would be less than 1, right? Let me try to do this backwards. So this is a proper fraction. How do I know? Because it's telling me out of 3 whole pieces that it was originally there's only 2 left. It's 2 out of 3. It's literally 2 out of 3. All right? Meaning there was 3 whole pieces at first. It was 3 whole pieces, but now we only have 2. It's 2 out of 3. It's 2 out of 3. Meaning instead of 3 out of 3, which would make it 1 whole piece, it is 2 out of 3. This is less than 1. 3 out of 3 is 1. Meaning there was 3 pieces and you still have the 3 pieces. This is 1. Does that make sense? This is one whole piece. Now, what we call improper fractions are, think about it, improper, because when you break something, it's in a million pieces, right? It's in so many pieces. So if you pick up one piece, that's 1 out of 10 pieces that it turned into. But what if you had like some piece just laying around from another broken thing? Well, if you add it onto this, let's see if I can write this backwards. This is what you call an improper fraction. They are numbers greater than 1. How do I know? Because out of 3 pieces, you managed to find an extra one. 4 out of 3 pieces. 4 out of 3 pieces. 4 over 3. Does that make sense? This is greater than 1, because 3 out of 3 would be 1 piece. 4 over 3 means there was an extra piece laying around. We added onto it. 4 out of 3 pieces. See what I'm saying? Wait, my brain is growing bigger. Does that make sense? All right. That's how. Oh my gosh, people, you should hop in on the live. So what I'm saying is, you need to know what a fraction is. Fractions aren't just this mysterious things. All right. Fractions themselves are numbers. They're numbers in their own way. However, they're represented by a situation. I'm going to use that as for a test. All right. So, for instance, you tell me, is this number greater than 1? Hold on. Is this number greater than 1? It's hard to write backwards. Is this number greater than 1? Can you guys see that? Is this number greater than 1? No. How do we know that? Because the numerator is smaller than the denominator. Does that make sense? This number is less than 1. It's less than 1, but is it negative? No. It is literally between the numbers 0 and 1. It's somewhere in between. It's in between these two numbers. How close is it? It's probably closer to 0, because 1 out of 4 pieces you're talking about is less than half, right? No, 4 over 1 is not 1. 4 over 1 means, this is what 4 over 1 means. Okay, so you had 1 over 1, meaning you had one whole piece and you still had one whole piece. This is literally 1, right? So now, magically, you found a piece over there, but you still had that one piece, right? So that's 2 out of 1 piece, right? Like, imagine you had broken glass. There's a red broken glass, right? Red broken glass. You picked up a green piece of glass and you added on to the collection. Or you had a red glass here, you just picked up a green one. You're still counting the red. It's 2 out of 1 piece, all right? 2 over 1. It's 2 now. Now it's 2. 2 out of 1, it is literally 2. That's what you call an improper fraction. Dang it. You know how hard it is to write backwards? Collab with speed. This is 3. This is 3. 3 out of 1 pieces. 3 out of 1 is 3. Now, here's the thing. People think this and this mean the same thing. These are two very, very different things. These are very, 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 very different things. 1 out of 3 whole pieces, meaning you had 3 pieces. You only had 1. 1 out of 3. This is saying I had 1 piece of pizza, 1 out of 1, then 2 pizzas, and then 3 pizzas. This is less than 1. This is greater than 1. Does that make sense? Am I following with you guys? There's a big difference. This is not the same as this. This and this mean 2 very different things. 3 out of 3 is 1, yes. Meaning you had 3 pieces on the ground and 3 of them were still there. 3 out of 3. The reciprocal, these are reciprocal of each other. Literally, they are reciprocal of each other. Does that make sense? These two mean something very, very, very different. These are not the same. All right, we got understood? Thank you for the roses. Thank you for the roses. So now, when you think of fractions, in your head, just put a pie chart in your head. Put a pie chart in your head. I did this in the video. Hey, what's going on? I did this in the video, and some of you guys ain't watched the video. I need you to put this into your head. All right? I want you to be able, if you have a piece of paper or something, I really do want you to follow along. These are the most important ways to cut a circle. So make a circle. All right? So, making a circle cut in half. Dang, that was not half. That was terrible. So, boom. So, you got pizza, cut it in half. We're just going to do something over 2. Dang it, backwards. Okay? This is the first one. The second one I want you to write, I want you to do this. You know that peace sign? You know that, like, hippy-dippy sign? I don't know if you guys are old enough. This is the third or the second one I want you to make. This right here. This is going to be over 3. Okay? So, here's what I'm about to show you. Alright? These two, this is something else that kids get very, 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 very wrong all the time. So, some kids will do 1 plus 1/3. Right? And they'll say 2 over 5. No, that is so wrong. It's not the right answer. It is not the right answer. It is not the right answer. 1 over 3 is not 2 over 5. Alright? That's not how it works. 1 over 3, watch. 1 over 3, that means 1 out of 3 pieces. Boom, color 1. This is 1 out of 3 pieces. Now, 1 and then half of a piece. You're going to have that. Now, how the heck would I find out the answer? Alright? I'm going to show you. Alright? 1 over 2 and 1 over 3. The only way you could do this is if you know your multiplication. If you don't know, this will look like complete magic to you. Alright? If you don't know, this will look like complete magic. Alright? 3 and 2. 3 and 2. They have a multiple that they have in common. It's called the least common multiple. Meaning if I count by 6. 3, 6, 9, 12, 15, 18, 21. Alright? Those are the multiples. 2, the multiples of 2 is 2, 4, 6, 8, 10, 12, etc. What is the least common multiple that they have? Least common multiple, if I were to count by these numbers. 3, the least common multiple, 3, 6, right? There you go. And then 2, 2, 4, 6. So what I got to do is change this somehow into 6. How do I do that? Who can tell me? By multiplication, because you got to multiply. What do I got to do to change 3 into 6? Because I need to make this into 6 pieces. We need to make these both into 6 pieces. So, someone who said 32 plus 35, that is wrong, and I really need you to pay attention. Multiply by 2. Alright? Times 2. Times 2. Alright? Now, that's kind of hard to visualize. Times 2. Top and bottom. Now, what do I got to do to this side to make this 6 with multiplication? What do I got to do with this side to make it multiplication? I mean, to make it 6. To make the bottom 6. What do I got to do? What do I got to do to 2 to turn it into 6? Multiply by 3. So, times 3. Dang it. Don't worry, we're going to do a lot of examples until you guys get it. Alright? So, times 2, times 3. Times 2, up and down, times 3. The reason why is because we want to get the denominators the same. 2 times 1 is 2. 2 times 3 is 6. So I'm going to do it on the back. So 2 over 6. And then 1 times 3. Or no, 1 times 2 is 2. I already did this one. 3 times 1 is 3. 3 times 2 is 6. So 3 times 1 is 3. 3 times 2 is 6. So you get 3 over 6. How did I do 6? There you go. And boom. In the back, now you have 2. Oh, that 2 looks terrible. Alright, so you got 3 over 6 and 2 over 6. Alright, so now we can add them. 3 over 6 plus 2 over 6. You add the top, you get 5 over 6. And that's your answer. Now, if you did not get what I said, please say, I don't get it. And be honest, this is the time to ask. This is the time to ask. This is the time to ask. If you do not know how I got this, please tell me. I had these couple questions and I think I got it wrong. Exactly. Listen, thank you for being honest. Because nobody knows how to use fractions to start off. It seems like, all right, thank you. All right, I'm going to do it again. So this one, I'm using a different number. That's a little bit easier to like conceptualize. I hate that. Is there a way to make this like flip? I forgot about you. You guys are still fixated on that. All right, someone give me 2 numbers. Anybody? Easy numbers. Actually, I'll pick them. I hate writing backwards. Let's do. Oh yeah, I got one for y'all. All right, let's try this. Oh yeah, the Krusty Krab pizza is the pizza for you and me. All right, so okay. Yeah, I got this now. Okay, so now so if you have a piece of paper, make this a circle with a 3 and a circle with a 4. This Ring camera is like a little too bright, but you know. Make this. So we're gonna do. Let's do 3 over 4 plus 1 over 4. 3 over 4 plus 1 over 3. Let's do that. So let's color this in. Oh yeah. This is good. This is real good. This is delicious. All right, let me calm down. All right, let me just ease up. See, when I do math, I get to acting different. I don't care. All right, we got 3 over 4 plus 1 over 3. Oh yeah, this is good stuff. We cooking now. Dang it, backwards. We got this. Now, is this 4 over 7? Put in the chat. Is 4 over 7 the right answer? Is that the right answer? Thank you. It's a nice background. You know, I work hard for it. Is 4 over 7 the right answer? No! What the flying flew do? Let's say I don't know how to multiply, right? I don't know how to multiply. You're going to need to know how to multiply. Thing is, you need to make these two the same type of pizza. Meaning, cut it into the same amount of slices. So if this is 4 slices, this has to be 4 slices. That's kind of hard. So what number? Do you want to know a secret? It's kind of hard, but whatever. If you really don't know what number is the least common multiple, what's 4 times 3? What's 4 times 3? 4 times 3. It's 12. Anytime you don't know what the least common multiple, forget about that. Do 4 times 3. It's 12. That means I have to make both of these pizzas into 12. So this is 4 slices, right? So to change 4 into 12, I cut all of them into 3 extra pieces. So 1, 2, 3, 4 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's do it. So 1, 2. Now it's 3 pieces. 1, 2, 1, 2, 1, 2. So now look carefully. Let's try to zoom in a bit. So now, this is colored in. Instead of 3 out of 4, it is now 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12. So now, these two mean the same exact thing. What did I do? I wanted this to be 12 because 3 times 4 is 12. But I gotta change this into 12 pieces. Alright? So now instead of 3 out of 4, you can still see where it's 3 out of 4. I changed them into 3 pieces because that's times 3. Now I have 9 out of 12. Same thing. These are equivalent fractions. Plus, now, this is 1 out of 3. What do I gotta do to each slice to change this into 12? Who could tell me? Anybody? What do I gotta do to each slice to change it from 3 pieces into 12? Anybody? What do I gotta do to each slice to change it into, instead of 3, into 12? Times 4. Very good. So I'm gonna cut every single one into 4 pieces. So it's gonna be 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Alright, so looky here. So instead of 1/3, can you guys see that carefully? Alright, so let's count. These are colored. So there's 1, 2, 3, 4 out of, so it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So instead of 1 out of 3, it is now 4 out of 12. So what I did, I cut all of them into 4 pieces. So now, instead of 1 out of 3, it is 4 out of 12. 4 out of, dang it. So, that's what we have. So now, we just add the top. Was 9 plus 4? Was 9 plus 4? You get 13. And then the bottom stays the same. It's 13 over 12. That's the answer. Oop. Does that make sense? We had this 3/4 plus 1/3. We found an equivalent denominator. We turned it into 12. And yes, it would be 1. I don't think it's 1.25. I don't think it's 1.25. Then we add 9 over 12 plus 4 over 12. We ended up with 13 over 12. Right? You with me? Did that make sense? If you're still lost, don't be afraid to say I don't get it. Don't be afraid. Don't be afraid. Don't be afraid. Does that make sense? I don't get it? Okay, thank you. All right, let's do another one. So your goal, when you have fractions, when you're adding fractions, not when you're multiplying fractions, not when you're dividing fractions, when you're adding fractions, when you're adding fractions, when we're what? When you're adding fractions, you have to make the denominators the same. You have to make them the same. Okay, let's say you don't know the least common multiple. Let's say you don't know. Oh, here we go. Start calling me random black people. Now I'm Speed. I look nothing like Speed. All right, here we go. So, least common multiple. If you don't know, don't worry about it. So let's say we had, dang, I had the right backwards. 3 over 7. Golly, that was terrible. Plus, I don't know, 2 over 3. I gotta find the least common multiple for the denominator. What's the trick? Remember adding this, we got to make the bottom the same. 7 times 3, guess what? It's 21. Dang it. So this got to be 21. And this got to be 21. Now, what do I do to 7 to change this to 21? Anyone? What do I do with 7 to change this to 21? Anybody? Going once? Going twice? You multiply by 3. Guess will take too long. Top and bottom. So now, we already got 21. What's 3 times 3? It's 9. And then what I gotta do, see here, by multiplication to change this into 21, multiply by 7. Someone already said it. Perfect. 7. Goodness gracious. 7 times 2 is 14. Dang, you know how hard it is to write backwards? And now, 9 plus 14, you get another improper fraction. You get, let's see, 23 over 21, which is 1 and 2. So you had, there's 21 pieces you had 23. That means you had one whole piece and then 2 left over. So that is 1 and 2 over 21. Are we still lost? Are we still lost? You want me to do another one? You want me to do another one? You can be honest. You can be honest. You want me to do another one? All right, I'll do another one. So, let's say you don't... Okay. In a situation like, let's say there is a least common multiple, right? I'll let you figure this out, right? I'll let you try to decipher this. What would be the least common multiple between these two numbers? Let's say we had 2 over 8. Let's make it 3 over 8. And 3 over 4. Okay. What would be the least... what would be the least common denominator that they have? So it could be 32. Let's say you just didn't know, right? You could just do 8 times 4. That will give you the answer, right? It will give you the answer. So let's do that, right? So I multiply this side by 4. Dang it, backwards. I'm going to say that a lot. Multiply this by 4. Now, obviously, there was a quicker way, but math works in that it's still going to give you the same answer. All right, 3 times 4 is 12. And 4 times 8 is 32. And then 8 times 3 is 24. And then 4 times 8 is 32. Dang it, that's a normal 2. All right, so that is, you're going to get the right answer. And then you add the top, 12 plus 24 is 36. Dang it. That 3, okay, it is 6. Come on, people. Over 32. Dang it, that's 36. All right, so this is the right answer. All right, don't get it wrong. It is the right answer. Whatever, you can critique my 2 all you want. Whatever, this is 2. So how'd you get it? Once again, I'll show you. You had 3 over 8 plus 3 over 4. We want to make these the same. Let's say you don't know the least common denominator. Let's say you just didn't know. You could just multiply the bottoms, right? 4 times 8, you multiply these, you get the same number on the bottom. That's all we need. When you're adding fractions, you get the same number on the bottom. Now, here's the thing. 36 over 32, this is the correct fraction. However, there's an easier way. So let me erase all this. By the way, there is nothing... I deal with people of all ages, and they're saying, like, math is hard regardless of what level. So never feel ashamed that you don't know math. It is a-okay. Trust me. I always say that. Anyways, so let's go back to the original question. You have 3 over 8 plus 3 over 4. All right? What numbers, let me erase this, look like a negative number. What number does 4 and 8 have in common? Watch this. So, least common multiple. Least common multiple. All right? So let's count by 4s. 4s, you got 4, 8, 12, 16. Right? Am I doing this right? Okay. I'm going to just stop right there. These are multiples, meaning if you were to multiply 4 times 1, 4 times 2, 4 times 3, 4 times 4, these are your multiples, right? 8, here's the 8 multiples. You got 8 times 1, 8 times... Do you already see the least common multiple? They have 8 in common. They have 8 in common. So all I gotta do, we already got 8 here. We gotta change this into 8. How do I change 4 using multiplication into 8? Anyone? How do I change 4 into 8? Anybody? Going once, going twice? Going once, going twice? Going once? Mister, what does x equal? There is no x. What do I do to 4 to turn this into 8 using multiplication? 5, 4, 3, 2, 1. Alright, you multiply by 2. Alright. Now why did I do that? Is because 4 and 8 had 8 in common as a least common multiple. So you have 2 times 3, you get 6. Dang it, it's normal 6 to me. This is working out my brain, people. 4 times 2, we established that we needed 8. Right? Plus, this stays the same. We didn't need to do anything. So 6 plus 3 equals 9. And then 8 stays the same. That's your answer. That makes sense? I feel like I lost some of you guys. Alright. Did that make sense? Is it clearing up? When you're adding fractions, you're lost? Alright, cool. Give me 2 fractions and I'll try to make it make sense. You also, listen, the thing also with fractions, one pair of fractions, I'm paying for grad to the, whatever. So one pair of fractions could mean the same thing. As we know, you guys probably already learned this. Or 1 over 2 is the same thing as 2 over 4. These are the same. They're literally the same number. They're the same number. They're the same number. Meaning, if you were to do 1 divided by 2, or like if I were to make the pizza example, 1 out of 2 slices, it's the same thing as 2 out of 4 slices. It's literally the same thing. So you can change the fraction so you can get the same number. Does that make sense? You could change the fraction to get the same number. So let's say I wanted to make the denominator 6. What do I gotta do to 2 to change this into 6? Anybody? Going once, going twice. What do I gotta do to change this into the 6 to have the same number? What do I gotta do to 2? Multiply by 3. I'm gonna post this on YouTube as well. So watch what happens. I do the same thing top and bottom. So technically speaking, 1/2 times 3 over 3. What is 3 over 3? What does that equal? 3 over 3 is just 1. Anything multiplied by itself, it's still the same, right? That goes to show you that 1/2 times 1 is still 1/2. Does that make sense? So, this is 1/2. 3 over 6, watch this. Look how 3 over 6 look like when I make it into I'm trying to make it look like this, all right? So this is 3, and all I got to do with 3 is turn it into 6. So cut it in half. Or multiply it, turn it into 6 pieces. We got 3 pieces right here. Watch this. Guess what? I got the same exact thing. So yes, you can change the fraction to something equivalent, and it still means the same thing. Are we still lost? It's okay if you are. Trust me, you could be lost all night. That is fine. Sometimes we need to keep thoughts inside. We do need to keep our thoughts. You should teach the butterfly method. All right, so this is what a lot of kids get very, confused. The butterfly method is when solving for x. Or when you're finding proportional relationships, the butterfly method works. I'm not going to show the butterfly method because kids get that confused with something else. So when you add fractions, do not do the butterfly effect. When you multiply fractions, do not do the butterfly effect. Don't do it. All right? Does that make sense? That's funny. When you're missing a value to x in a fraction, okay, that's where it works. This is not that. You just add, find the common denominator, you get your answer. Or if you multiplying fractions is the easiest thing. It's the easiest one. It's the easiest one. It is the easiest one. Like for instance, if I have 1/3 times 2/7, I just multiply straight across. 1 times 2 is 2. 3 times 7 is 21. That's the answer. Multiplying fractions is the easiest one. Right? So yeah, any more questions with fractions? So this is also where it gets tricky. The reason why I'm obsessing over fractions, because that's the things that that's the one that gets people the most. That and negative numbers, right? Yo, what's up? So fractions are the ones that people get messed up the most. I don't care if I do 100 fraction videos. I want people to know their fractions, all right? Thank you. I appreciate that. All right, so thank you so much. I appreciate it. I try to be a good teacher. If not, I'm going to keep trying. So watch this. Let's try what does a fraction mean before you're employed. All right, so some people, I asked them, okay, what is 2, dang it, backwards, 2 divided by 5, right? All right, I know that's 0.4, but let's say I didn't know. The answer is quite literally 2/5. It means the same exact thing. 2/5 equals 2/5, and you can think of it literally. Boom, that's your answer. So 2/5. Now, don't put this on a test, right? This is the answer. Don't put this because it's not going to ask you to put a circle. I'm just saying, you can visualize 2 divided by 5 is literally 2/5. Yes! The second number is the size of the pie. It's how many slices are in the pie, all right? It's actually the amount of slices in the pie. And the first number is the amount of slices, yes. So this is the amount of slices. Those are the total slices. How many times can 2 go into 5? It can go 2 out of 5 times. Does that make sense? All right. Do you want to add another fraction? Who wants to? Not raise your hand. Tell me if you want to add a fraction, multiply a fraction, divide, subtract, any of those. Tell me which one. The first one is the one I'm going to do. Add, subtract, multiply, or divide. Which one? Give me one. Multiply. Perfect. Multiply is the easiest one. I'm not going to do a negative number just yet. All right? But let's just multiply. Multiply, you just multiply straight across. straight across, straight across, straight across. So, all right, 5/7. I need to start on that side. Let's do. I think I'm gonna get stuck writing backwards. That's all right. It makes me different. I like to be different. 2/. Someone give me a number. Anybody? Anybody? I usually don't work with any numbers larger than 12, because if you know how to do up to 12, you can do everything. 6. All right. Okay. Just multiply the top and bottom. 2 times 5. It is 10. And then 7 times 6 is 42. Trying to do 2. There you go. Makes sense? All right. So when you multiply fractions, you just multiply straight across. Straight across. If there was a counter of how many 6 7s I saw, I'd be rich. All right. Anybody else? Another fraction question? Any other fraction question? Quick. Who can tell me what is 2 backwards? What is 2 divided by 7? What does that equal? What's 2 divided by 7? Don't need a calculator. What's 2 divided by 7? Anybody? No? See, that's the thing. You're trying to put it in the calculator. 2 divided by 7 is 2/7. Yeah. 2 divided by 7 is 2/7. What about 3 divided by 47? What is that? What's 3 divided by 47? It's 3. There you go. All right. Some people, and this is driving me crazy, right? Scale factor, right? It would be one shape. The new one has 2. The other one is 3. Is new divided by old, and then like they do this, and they're like, "What's the answer? What's the answer?" What's 2 divided by 3? I don't want the decimal. What's 2 divided by 3? Anybody? 2 divided by 3? It's 2/3. Yeah. It's literally 2/3. Now, if they say, give me the decimal answer, okay. Then you have to do the long division. Now, if they say, give me the decimal answer, okay. Then you have to do the long division. Am I still lagging? We lost him. Am I still here? Still here? Am I still lagging? Nope. Okay, cool. I had a call. I need to put on Do Not Disturb. But yeah. So when it comes to now, if they say change it into a decimal, okay, then you need to change it to a decimal. Like for instance, we now know that 1 divided by 5 is just 1/5, right? Yeah, it is 1/5. That is true. But anyways, yeah, this is 1/5, all right? But now if they say, okay, change it into a decimal, all right, so let me show you a little trick. So 1/5, I'm going to change this, I'm going to use this fraction. Make a star. Now you have 5 pieces. This is 1 out of 5, right? Makes sense? This is 1 out of 5. Now, let's say I'm trying to get to 100. What? Let's say all this together equals 100. Backwards. let's say all these pieces, if they're all colored in, it would be 100. So 1 out of 25. What would I need this piece to equal so that when I add these all together, I would get 100? What plus what plus what plus what plus what gives me 100? All right, someone said 25. 25 plus 25 is 50, plus 25 is 75, plus 25 is 100, plus another 25 is 125. So it can't be 125. Anybody? It's 20. 20 plus 20 plus 20 plus 20 plus 20 is 100, right? I only have 120, right? So 20, this is 20%. So literally 20% is the same thing as 0.2. So 1 divided by 5 is 0.2. Does that make sense? Now, let's say like, oh, how do you know it's 20? I'm not gonna lie. If you master multiplication, all of this starts making sense. It starts making sense very easily. Because let's say you didn't have a calculator, because some tests, you're not gonna have a calculator. Let's see if I can do this long division without it, what's it called? Looking backwards. So, we're doing 1 over 5, right? 1 over 5, we're trying to change that into a decimal. We're going to change this into a decimal. So we're going to divide, all right? Goes in here. All right. I did this backwards, my bad. There you go. Remember, it is 1 divided by 5. So 1 goes in, 5 goes out. 5 goes in, can 5 go into 1? It cannot go into 1. All of 5 cannot go into 1. So that means it goes into 1 0 times. Does that make sense? Minus 0. 1 minus 0 is 1. Oh, mister, I don't have any more numbers left. Yes, you do. You got plenty numbers afterwards. It's all the same number, but you have plenty numbers. Bring that brother down. Put that decimal point here. How many times does 5 go into 10? 2 times. So 5 times 2 is 10. So 5, we're done. That's it. Once you get 0, it's over. That's it. 0.2, 1 over 5. So what is 1/5 as a decimal? It's the same thing as 2/10. All right, I'll do one more and then I'll call it a night. I know we forgot. So here's the thing. Let me talk to you for real, right? Here's the thing. Circumference is very easy. Circumference of a circle, it is just 2 pi r. That's it. Sometimes you don't even need to change pi into a number. It would be 2 times pi times the radius. Radius is just the distance from the middle of the circle to the edge of the circle. It's 2 times the radius times pi. That is it. So I'm going to say this is for real. All right? So when it comes to like numbers in school and things like that, I get it. It seems like what is this for? When you're a kid, and even when you become an adult, you're in a very sheltered, oh, thank you, no problem, a very sheltered environment. So you're not going to see why it's useful. If I were to tell you right now, learn Chinese, you're like, why? Why would I ever need to know Chinese? Well, if you find yourself in a situation where learning Chinese would be very beneficial for you, you'd be very thankful for the Chinese that you learn, right? Now, different from Chinese, everybody uses math. Everybody uses math. Everyone doesn't use Chinese. Now, it would be very helpful to learn Chinese. However, math is something that we all use. And the thing is, like, for instance, me, I worry about the food that I eat. So I'm going to just spill out a whole bunch of numbers for you. I am trying to eat about 2,400 calories in a day. Now, I burn without doing anything 1,600 calories. Let me write this down. All right. So I need to burn. I want to eat 2,000. Dang it. This is where math becomes very important. This is how many calories I can eat in a day. But I burn. What's up? I burn this much. Meaning my body without doing anything. Nothing. If I lay down all day, I'm going to burn this much. Now here's the thing. This is how much I burn. This is how much I'm eating. Right? So I'm going to still have some more calories left over. Any calories that's more than your caloric burn is going to make you gain weight. So I have 800 calories left. I ate 2,400. I burned this much from doing nothing. I have 800 calories left. Here's the thing. How do I burn 800 calories? Because in order for you to lose weight, you have to burn all the calories that you have and then some. It's called a caloric deficit. I already said, there's a lot of numbers. So 800. Now here's the thing. You could just think about it like, burn 20 here, 30 here. But if you break it down into groups, dividing, this number starts getting less scary. So if I walk a mile, I'm going to burn about 200 calories. So if I walk a mile, that takes me about 20 minutes. So 800 divided by 200 would tell me how many times I can walk a mile. Every time I walk a mile, it's 200 calories, 200, 200, 200. So how many times can 200 go into 800? 4 times. So that gives me the answer of 4. That means on 4 separate occasions, I need to walk a mile, and that'll burn me my 800 calories. This math I do in my head. Does that make sense? Most people do not do this. And what they do, they just try to walk 800 miles or 800 calories. They try to burn it on one go. No, you don't need to do that. Can you do polynomials? I have a math test tomorrow. You know what a polynomial is? You got binomials and you got polynomials. All right. So to my knowledge, I think a polynomial is a 2-factor binomial. I think a polynomial is just a number that has multiple terms in it. So I think this is a let me look that up real fast. So this is what you would call a trinomial. Or no, this is a binomial because it has 2 terms. 2 terms. The 3 is backwards, dang it. This is a polynomial, right? Because it has 1 term, 2 terms. This is algebra talk. Alright? Alright, any more questions? If the fractions made no sense, so this is my challenge to you. Try to add some fractions with unlocked denominators. The way you would do that is, if you really don't know the least common denominator, you're just going to multiply the denominators together. But I encourage you, memorize your multiplication table. Your 1s, your 2s, your 3s, all the way to 12. All the way to 12. All the way to 12. So if you don't know 1 through 12, things don't make sense, right? Because you should see this right here, this number right here, and automatically, if you see this, you should automatically know this is 3 over 5. How do I know it's 3 over 5? What number is 21 and 35 have in common? What is the most common, the greatest common factor? 7. Let's do that. This is 3 over 5. Don't worry, I'm going to do these more often so you can see it and it makes more sense. Alright? These two mean the same exact thing. Let's see who can get this first. Let's see if we can get this first. How can we reduce this? Oh, that's it. Sorry. Dang it. That's supposed to be a 2. What's this in this most simplest form? What's this in the most simplest form? Anybody, first person up. See, if you don't know your multiplication, you'd recognize that there's a number that's 6 over 7. There you go. Both of these have 7 in common as a fraction. I mean, as a factor, right? We get 6 over 7. Gotta know your multiplication. If you know your multiplication, things like this, they're just there to scare you. Ooh, let's do another one. Dang it, I keep messing up. How do we reduce this? You want to know a trick? Whenever a number ends with 0, if they both end with a 0, you can just cross out the zeros. If they both end with 0. If they don't end with 0, do not cross out the zeros. Someone got it? No, it's not 60. Not 60. One number does 12 and 30 have in common. It's the biggest number they have. See what I'm saying? If you know your multiplication, you'll know that 6 is the biggest number that they have in common. (12 divided by 6 is 2. And 13 divided by 2 is 15. So I'm going to leave you with that. My goal, matter of fact, don't even worry about adding, multiplying the fractions. Don't even worry about that. Do not even worry about that. Do not even worry about that. I'm going to tell you what you need to worry about. Worry about your multiplications 1 through 12. 1 through 12, that is it. Don't worry about nothing else. If you memorize your multiplication, everything else makes a lot more sense. Your multiplication. If I say 12 times 7 and you're and you don't say 84, it's a problem. If I say 9 times 6 and you don't say 54, it's a problem. If I say 8 times 6, you don't say 48, it's a problem. See what I'm saying? 5 times 8 and you say 40, something not 40, it's a problem. You got to memorize your multiplication facts all the way to 12. 12 times 11, what is it? It's 132. You got to memorize it. 10 times 8, 80. 2 times 9, 18. 6 times 8, 48. 6 times 11, 66. Give me another one. 1 through 12. 7 times 4, 28. 5 times 6, 30. 9 times 4, 36. Gotta memorize. Just like I do that, you gotta memorize it. Practice it. Start with the ones. Don't even start with the ones. Everyone knows the ones. Can you help me out with math? I need it. I'm trying to help you guys out with math. I'm telling you, the number one thing, I don't care if you feel like it's too baby. Nothing's too baby. You need 12 times 2.5. That's 30? Yeah, it's 30. But don't even worry about the decimals. Don't even worry about the decimals. Don't even worry about the decimals. Just 1 through 12. Just 1 through 12. 12 times 10, 120. 12 times 7, 84. 12 times 6, 72. You gotta memorize the multiplication facts. The ones is 1 to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The twos, all your even numbers, right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21. Or 22, 24. See, I still mess up. Threes, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. All the way up to 12. 4, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, 60. 6, 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72. 7, 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84. 8, 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96. 9, 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99, 108. 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. 10, I already said that. 11, 11, 22, 33, 44, 55, 66, 77, 88, 99, 110, 121, 132. 12, 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144. 13, 13, 26, 39, 52, 65, 78, 91, 104. Just the 12. You just need to know all the way up to 12. 1 through 12. 1 times 1, 1 times 2, all of that to 12. Practice. Just like I did, right? The back of your composition book, it has the times table. So if I were to say 30 over 40, they both have 10 in common. But you won't know that unless you know your multiplication facts. Make sense? Ooh, how about this? How about this? Dang it. I'm trying to do this properly. What numbers do they both have in common? It's the largest number they have in common. What do both of these numbers have in common? What number do they both have in common? 4 over 6 is a reduced version, but it reduces further than that. This is why you gotta know you're up to 12. (24) divided by 12 is 2. 36 divided by 12 is 3. Now, here's what happens. On the test, they're probably going to give you something like this. You're like, how am I supposed to know that? If you recognize now, these are both zeros. Zeros, you don't even need them. And then 24 over 36, they both have 12 in common. Oh, what the heck? Listen, forgetting is one thing. Also, too, I'm in this now because now TikTok is being tripping. All right? Everything that you learn, if you don't use it, you're going to forget. You're going to forget. You're going to forget. It's okay. Right? Like for me, I don't be using Creole as often, so I'm going to forget. So, si m'oubliez parler Creole, sakte un point avant, you know, see what I'm saying? I don't practice enough, so now I sound crazy, right? Cuando aprendo, see? I didn't practice it, so now I'm like, let me just avoid it. No, man. Gotta do the hard stuff. And then it becomes easy. Then life becomes a lot easier. It becomes a lot easier. So therefore, when someone said, hey, man, I got this like accounting job, pays like $120,000. You good with numbers? Yeah, numbers are easy. See what I'm saying? So I'm going to leave you with that. I'll do this another time. I'll do another YAP session. I'll do another method video. Doesn't matter. I really focus on fractions a lot. A lot. A lot. When I tell you, this is what you need to do. Practice your multiplication. Practice your multiplication. I'm not going to lie. I kind of want this to get to 20,000. I'm not going to lie. I kind of want this to get to 20,000. I'm not going to hold you. Dang, what got... Oh, 20,000. All right, that's it. I'll catch you guys later. Thank you for tuning in.